Good morning, students. You're welcome to CHM 303 class. The topic for today is aromatic and alicylic compounds. What are aromatic compounds? They are chemical compounds that contains a conjugated planar system, a ring structure with conjugated electrons, pi electrons. Now, if you look at structure 1, you find out that the double bonds are alternating, and the double bonds, if you look at the arrow here, it can move from one position to another. That is, it is not static. So you have this double bond here in structure 1 moving to the next one, and as that is happening, the next one is also moving. So you have the pi electrons. You know, there are 2 electrons that make a bond. So there are 6 pi electrons in the ring. These 6 pi electrons are in consistent motion, moving around the ring, taking different positions at the ring. And so if you can have the double bond in this position in structure 1 and also have it in an alternating position in structure 2, therefore showing the delocalization of the electrons in the ring. Now these two structures combined together gives us a resonance hybrid, telling us that the pi electrons in the ring are delocalized within the ring. So any compound that has this type of phenomenon is called aromatic compound. So what are alicyclic? Alicylic compounds are also ring structures, but they do not have pi electron delocalization or aromatic character. For example, in cyclohexane is a cyclic alkane. This is a cyclic alkane. So you can say that alicylic compounds are cycloalkanes, cyclopentene, cycloalkenes, cycloalkynes. Compounds that do not have electron delocalization within the ring. They do not have aromatic character, but they are a ring structure. An example here is cyclohexane. If you can see, there is no double bond in the ring, while in cyclopentane, the pentene is an alkene. Cyclo means it is what? In a ring. So you have a 5-membered ring alkene called cyclopentene. It has only one double bond, and so also you can find that also in cycloalkane. So these are the differences between the two compounds. Okay, so what are the examples of alicylic compounds? The first one, cyclohexane, which belongs to the cycloalkane family, a ring, 6-membered ring cycloalkane. You also have cyclopentene, a 5-membered ring cycloalkene. You have cyclopentine, a 5-membered ring alkyne. Okay, so wherever you see the name cyclo, means that what it is a ring structure. Now an interesting structure is here, where you have a 2 ring connected together. Now one is a 4-membered ring, the other is a 6-membered ring. Now this is acting as a side chain. A side chain is substituent because it is small, so the smaller ones will be the side chain, which is the substituent. Now this is cyclobutane, this is cycloheptane, but because this is a substituent, so you call it cyclobutyl, just like you have alkyl groups as substituents. So the cyclic ring also can also be a substituent. Okay. Examples of aromatic compounds. The first one is benzene. We all know that when you think about aromatic compounds, the first compound is the benzene ring. The benzene ring, that's the foundation. Okay, so this is the benzene structure. Now on this benzene, you can have substituent attached to it, and once there are substituents attached to it, it carries a different name. Okay, so if you have an amino group that is connected to a benzene ring, then you have aniline. Now, also an interesting thing about aromatic compounds is that you can have more than one benzene ring fused together, like you have in naphthalene. Also in the naphthalene, you have, this is the first benzene ring, this is the second one. If you have the three bonds in this first ring, then this will be what? 2. If you have 2 here, this will be what? 3. Why? Because the electrons are delocalized within the ring. So if this moves here, it can also move here, and then the electrons are delocalized. So there's a way the bonds are being put in more than, when you have more than one ring, that shows the delocalization of the electrons. You can also have 3 benzene rings fused together, as you have in anthracene. Okay. The last thing we are looking at is when you have the classification of organic compounds, you have aromatic compounds. We also have aliphatic compounds. Aliphatic compounds are compounds that do not have aromatic character, just like the alicylic. The alicylic also fall under the aliphatic compounds. Okay, and the aliphatic can be a straight chain, could be a ring structure, but they don't have conjugated electrons or double bonds within the ring. Okay, so the first difference there is the meaning, which benzene ring is used to define the 2. Okay, one is with a benzene ring, the aromatic is with a benzene ring, the other is not. Okay, so when you look at conjugation, which has been mentioned, the localization of electron, you find that in aromatic, it is absent in aliphatic and also alicylic compound. Now there's a way you test in the lab if a compound is aromatic or if it is aliphatic. Now, aromatic compounds will always burn with a sooty flame, while aliphatic will burn with a non-sooty flame. Okay, so these are the differences between aromatic, the general class, aliphatic compounds. Right, thank you so much for paying attention in this class. We have come to the end of the class. See you next time. Thank you.